Hello, Dr. Clarence, you're on mute.
Hello, Mwamini.
Hello, Dr. Clarence, I can hear you now.
Yeah, thank you so much for being here. Now I'm having a little bit trouble on sharing my screen.
That's okay. Should I project for you? Should I project the screen? I can project the presentation. Okay.
Yeah, sure. No problem.
Let me do that. Let me do that for you.
You can do that. Yeah, sure.
I think you can start, Dr. Clarence.
Yeah, thank you so much. I can see the. Yeah, sure. So welcome everyone in this training session. It's a training session, our first webinar series, which is will cover the first module of water supply under the project German-Tanzania GreenTech Innovation Program for Modernization of the Water and Wastewater Sector under the International Water Managers for Industries in Tanzania. My name is Dr. Clarence Paul Kisiki. I'm the development and trainer of this particular session for Module 1 and Module 2. And welcome all on board to get started with this training session. Please, let's go to the next slide. So the session will cover the outlines displayed in this slide. We'll first look at the water occurrence, water cycle, withdrawal and consumption, and also we look at the groundwater and surface water, and also reuse water, for harvesting, supplementary water supply sources, and meeting your water needs. And finally, we'll go into conclusion. This module came due to the growing demand for skilled water management professionals, and there is a need for sustainable water resource conservation, and also we need to bridge the gap between theory and practical application in water used in the industrial sector. As we all know, we have been having several industries in our country, and also we are having water managers in these particular industries, but sometimes we find some industries having water managers who are sometimes unprofessional, like they are not water professionals. And also we find them having some hardship in managing water, specifically looking at the different aspects which will enable them have access to water throughout the year. So that is why IWAMI came up with this blended learning program, which is market-specific content for the Tanzania context, and it will focus on practical application and real-world problem solving. So at this particular time, I think before we continue with the session, it's time we know each other. You know, it's always good for a lecturer to know who is attending the class, what is your name, your overview for the your background, and also would expect to know what is your expectation in this particular program. So I would hand over to Mwamini to take a role of having everybody introduce themselves, and thereafter we'll continue with the session. Over to you, Mwamini.
Thank you so much, Dr. Clarence. So everyone, do you want to, I don't know, I'll just open the floor for volunteers. And if I don't get volunteers in 10 seconds, then I'll just start calling people according to the alphabetical order. I think Teams here has made it easy for us. So any volunteers who wants to go first? It'll be nice as well if you turn on your camera so that we can see you. No? Okay. So I think Benjamin is up. Thank you, Benjamin, for volunteering.
Yes, thank you. Just a bit. Okay. Thank you, everyone. My name is Benjamin Shedrack, water treatment manager for Davis and Shirtliff, Tanzania. Yes, and I have some experience, like 3 years now, in water treatment, where we we provide the solutions for Tanzania, and just to aiming to improve the lives of Africa. That's our main core target. Now, and the expectations for the modules, I'm expecting to understand different technology, especially the current one, the modern one that we are using, on how we can purify the water even after usage of it, and how we can reuse the water. The main target is see how we can try to minimize the wastage of water, especially the groundwater. As you have seen, currently there is a lot of drilling that is happening around Tanzania, so we are disturbing the natural aquifer. So I would like to know how we can try to minimize the usage, minimize the waste, and see how we can reuse the water. That is my expectation on this. Thank you.
Thank you so much, Benjamin, for that introduction and overview. Next, I'd like to call Concedo Conrad. You're next. Concedo, you're probably on mute if you're struggling to speak. No? Okay, from Concedo, we go on to Damas Mbaga.
Yes, hi. My name is Damas Mbaga. I'm working as a water resources expert within African Wildlife Foundation. I have 15 years experience in water resources management. I was working with the Ministry of Water, African Wildlife Foundation. Now currently I'm working with the WWF. I'm implementing the project on water sanitation and hygiene and integrated water resources management. So my expectation in this module is to learn more about groundwater resources management, water surface water resources management, extraction, as well as conservation and the treatment method. Thank you.
Thank you so much, Damas, for the overview. Up next is Dinas Lorian. Dinas, are you ready? No? Okay. Next is it EJ or Eji Lorian?
It's Eji Lorian.
Okay, Eddie. Okay.
For me, actually, I'm from the company known as Star Expert. I'm a business development manager. We deal with water and the solar. So I wanted to learn actually on the issue of water treatment, because where I'm living, like the guy from Defenshatrif said, people are drilling water, but they don't treat the water. So yeah, so I want to know about this water treatment actually. This is the main issue which I'm here to learn.
Thank you so much, Eddie, for that. We have a module dedicated on water treatment, and so don't worry, hopefully you learn about that, but also Dr. Clarence is an expert. Will be ready to address if the issue is within her 2 modules. Yes. So
Okay,
next is Flora. Thank you so much, Eji. Flora. Okay. Okay. Maybe up next is Lamek. Lamek, you're on mute. You mind unmuting?
Hello, everyone. My name is Lamik Takome. I'm working at Geotech and training as a sales engineer, pumps and water engineering. My section for this course is about underground water association and harvesting, water treatment, as well as wastewater management. That's the expectation I expect from this training. Thank you.
Okay, thank you so much, Lamek. Maduhu, do you want to go next?
Hello.
Hello.
Good afternoon, everyone. My name is Madu Shija, working at Energy and Water Utilities Regulatory Authority, famously known as EWURA. I have been working for more than 5 years in the water sector, both as a service provider and at the same time as a regulator. My expectation to this webinar is to understand various approaches used in the management of water and sanitation infrastructures. Thank you.
Thank you so much, Madu, for that overview. So I'll just go back one last time to Damas. Damas, are you ready? No, wait, Damas already went. Yes, sorry. It was Concedo. Concedo, are you ready?
Yes, I'm ready.
Okay.
Good afternoon.
Good afternoon.
Yeah, I'm Concedo Conrad. By profession, I'm an environmental expert. I've been in this industry for the EIA and audit for more than 10 years. All in all, my expectation is to get more knowledge on the all course modules which have been presented from from module 1 to module 4. Thank you.
Thank you, Concedo. Elizabeth?
Yes. Hello, everyone. My name is Elizabeth from Women Tech Network. I am expecting to learn more about the water management for sustainable future. Thank you.
Thanks, Elizabeth. Jasmine? Jasmine? No? Okay. Sophia is probably our last speaker for this session. Sophia, do you mind introducing yourself?
My name is Sophia Sylvester Sumbuka. I'm a graduate of bachelor degree in water resource and irrigation engineering from Water Institute. I'm happy to be in this training.
Thank you so much, Sophia, and everyone else who took time to introduce themselves, but also just give an overview of the expectations. So I'll hand over to Dr. Clarence. After gathering that input from everyone, maybe we can now officially start.
Yeah, thank you so much, Ms. Mwamini, for the introduction of the participants. I am happy to hear from all of you and the expectations raised from all of you. And as the content of these modules indicated, we'll have 3 more modules. So whatever will not be like deeply covered in this module, we'll find them in the next coming 3 modules. So we'll just have Q&A session at the end, and we'll be able to elaborate what was not, like what you didn't find it covered well in this, or like which you didn't get properly in the module session. So welcome all on board. We are getting started with the training of our first webinar series. And today's lecture will be on water supply. As the content indicated, this water supply module will explore aspects of water resources, occurrence, usage, and sustainable management. It will also provide understanding on water movement through the environment, and also extraction and consumption. And finally, we'll look at the innovative strategies to ensure sustainability, looking at the different other sources of water that can supplement the current water sources available.
Question and answers.
Sorry, it appears that Damas is struggling to see the presentation. Is this the case for everyone else?
The answers.
And for others,
No.
please, you can see, right, Dr. Clarence?
Yes, yes.
Comment. Nacho. Let me just do this. Give me comments.
If everyone can see the presentation, maybe it's my computer. Let me switch off, then I'll join again.
Thank you. That maybe could be a solution.
All right, so let's continue with the session. So as I said, we'll start with the water occurrence, cycle, and withdrawal and consumption. If we look at these 2 images, we'll look at the first one, which is labeled water cycle. And looking at this water cycle image, we'll see like we have different processes that take place in day-to-day earth operation, and which leads to having our surface water bodies, to have groundwater system, and having atmospheric water, or fogs, which can be extracted, as we will see later. So looking at this image, we'll see we have surface water bodies, and we have plants, which, can you please go back, which where the evaporation takes place, and evapotranspiration also takes place from the plants. And as this evaporation takes place, it goes to the atmosphere, and some other processes such as condensation takes place, and finally we'll have precipitation, which comes back as rainfall. And as we have rain coming back, we may have some interceptions and evaporation before the water even reaches the ground, and finally it will reach the some part of the rain will reach the ground, and as it reaches the ground, we'll have also some evaporation, we'll have infiltration, we'll have surface runoff, and the infiltration passes through the unsaturated zone towards to the water table, where it recharges the groundwater system, and that is how we get the groundwater system. If we have the rocks which can accommodate water, which are porous and or fractured, that is how we get the groundwater system. So this cycle is continuous, and that is how we end up having the water distributed in our earth. So if we look at the second image, we'll see different distribution of water on earth. We'll see we have so much saline water. Like most of the water available on earth is saline water, which is about 97.5. And also we'll see the freshwater is only 2.5%, which is again divided into surface water bodies like lakes and rivers and other water bodies such as man-made dams. And also we do have groundwater system, which is all coming from this 2.5%. So if we look at this, we can see the amount of fresh water we are having compared to the saline water. Fresh water is not so much, so we need efficient use and conservation for its sustainability. Let's go to next. Yeah, if we look at the withdrawal and consumption of water, we do have different sources. We will see in the next slides. But if we look at the image, the first image, which is colorful, we'll see that we have the statistic of the water withdrawal and water consumption worldwide, which has a projection of 2025, which the year we are in now, and other projection to 2040. So if we look at this image, you'll see the withdrawal and consumption from 2014, 2025, and 2040. It's increasing, and all other uses also, they are increasing. If we look at the power generation, industrial use, municipal use, and agriculture, we'll see all increasing with time as the projection shows, and also the consumption also increases as the withdrawal increases also. So if we look at this, we can understand that we are having water abstraction and water consumption increase from day to day, and we are having same water sources, and also we are having other issues of climate change. We are having other issues of misuse of the water. We are having other issues of, specifically for us developing countries, we don't give so much effort on the water reuse. So it's time now to wake up and see how we can efficiently use this resource for its sustainability for our future generation. So if we look at the table, which shows the withdrawal in Tanzania and German, we'll see that the difference, which is if we look at the hydropower use, German uses 54.8%. This is percent of water, of total water withdrawn in the country, but Tanzania uses 50% for the same purpose of hydropower. But if we look at the industrial and mining, we see that we have German has 23.2%, but Tanzania has only 2%. So this tells us that we are still okay. This is clear that we are not so much industrialized, but like these are developed countries. But again, we also need to do something on this. If we look at the other uses like livestock, fisheries, and wildlife, the information was not provided with the German, but Tanzania uses 2%. For irrigation also, we see that German uses 1.3%, but Tanzania uses 40% of the water withdrawn. For this one, I think we will ask somebody from German to give us the reason why they are using so little water. Are they importing so much food, or what is happening with their agricultural irrigation water use, or they are having so much rain? I think we will have that answer later. But for domestic now, we see German uses 20%, but Tanzania uses only 6% for the domestic use. So if we look at this, we can tell exactly, we know the level of development increases the level of water consumption. Because if we look at the developed countries or regions, or the household which has a high living standard, even the amount of water that is used per day is even higher than the low living standard family, since for the developed or high living standard families, they use like so much, like in the showered water system. They use like they have kitchen facilities which is connected with water, flowing water all the time. But for the low living standard, you find them having like, just if you fetch water with buckets, you cannot use as much as somebody who is using piped water, which is flowing throughout day and throughout a year. So if we look at this, we can see the big difference in the water use in the developed and developing countries. Let's go to the next. So in this particular area, we will look at the abstraction and the water treatment processes. If we look at the abstraction, as I said earlier, we do have different sources of water in Tanzania, in other regions as well. So we have a lake and dams. We may abstract water also from direct abstraction from the water courses or standing water bodies. We may also have water from underground water, which is groundwater from aquifers and springs. We also may have water from the effluents or wastewater, which is treated. And also we may have water from rain, that is harvesting rainwater. We may also harvest fog, and also we may have water from the saline water from the oceans. And finally, all the water abstracted should be treated and then allowed to move into the transportation and distribution system to the end users. So after the water is abstracted from the particular source, it undergoes through coagulation and flocculation. It's then goes to sedimentation, filtration, disinfection, then pH adjustment, and finally storage and distribution. This topic will be covered in detail in the, I think it's third or fourth module of water treatment and reuse. Let's go next. So next, please. So as I said earlier, we do have different water sources. We have springs and shallow wells and deep wells. In order to get water from the groundwater system, we need to drill boreholes, which we will use pump to extract water, and this water is always need little treatment before it's allowed to go into distribution system. But the advantage of using borehole is it's the treatment needed for the groundwater, the water abstracted from the groundwater is not as intensive as the treatment for the surface water, since we know the surface water bodies, they are open. It's act as a buffer zone for the treated water, or sometimes some other industries or people may allow water to move into the surface water bodies without properly treating it. So usually treating surface water from the surface water bodies as abstraction, it's more intensive compared to treating water from the groundwater system. Since as water moves towards recharging the groundwater system, it's always the media where water moves through act as a filter, and the water will be filtered as it moves towards the groundwater system, where it will be stored for millions of years even before it's abstracted for use. Please have some other images, other informations in this slide. Yeah, so if we look at this image, we can see we do have different uses of water in Tanzania. We have water used for as water supply. I mean, urban water supply. We do use groundwater system for rural water supply. It is also used for agriculture. And as we can see this image, most of water or groundwater system is mostly used in the rural water supply. Since you find most of the villages, they are they don't have surface water bodies. So the easiest way to have water to supply to the rural area is mostly through having these boreholes drilled, which we expect at least we will find some groundwater. At least in your village, we cannot miss even one or two boreholes, which can yield significant amount that can be supplied in that particular village. So if we look at this, we also use groundwater as water for irrigation in agriculture, which is only 10%. In industry, we only use 2% of groundwater, and yeah, other uses such as fishing is also like 28%. Yes, Mamin, let's move to the next. Yeah, also apart from groundwater, we do have.
Dr. Clarence, sorry, if you could just adjust your camera a bit. I'm having a hard time seeing you. Yeah, there.
Yeah,
better,
I'm here. The problem is sometimes I'm getting difficulties in reading those images, because I think when they are displayed from your side, they really look faint somehow. Yeah.
Okay,
so now
I'll
you can
try
see me,
to
right?
magnify. Yes, I'll try to
All right.
magnify.
All right, thank you. So if we look at this particular point, as I said, we do have groundwater as a source of water for our daily uses, for industrial use and other uses. We also do have surface water as a source of water. And as I said earlier, the surface water is easily affected by pollution, easily affected by climate change due to high evaporation since it's exposed due to the direct sunlight and all that. So if we look at the surface water bodies, we may abstract water from river, from streams, canals, lakes, and dams. And if we look at these people carrying buckets on their heads, they are abstracting water from a lake, Tanganyika, but just by, it's not piped system, they are just abstracting using their buckets. And also in water abstraction, we may have different water abstraction points. We may have permanent water abstraction points like the one indicated in the right side down. And we may have temporary water abstraction points, which is floating bodies which are located in the river system, which abstracts water for treatment and distribution to the main distribution for intended users. Please go to the next. I think I have some more information with this slide. Yeah, now we look at the water reuse. Why do we need to reuse water? As we said earlier, we do need to come up with different supplementary sources in order to make sure that we are sustainably managing our current available water in order to have it sustainably managed for future generations. So, can you please try to magnify the image?
The next slide.
No. This particular image.
You need it magnified?
Yes.
Okay, no problem. There?
Not yet. I've not seen any magnification yet. So we do have two terms, which is indirect potable water use. No, please. Indirect potable water use and direct potable water use. After using water, after abstracting water from whatever source, we do our normal treatment routine, and then it will be directed to the water users. After water is used in a particular use in an industry or any other use, or in agriculture or any other use, or domestic, the water can be recycled for reuse. So if water is recycled to a point that it's pure, that it can be directed back to the water system, we call it a direct potable reuse. But we may to a point that we can just subject it to the water treatment system or to other to water buffer system like lakes or rivers or any other surface water bodies where water can be redirected, and then it will be reused indirect potable reuse, where the water has to be retreated before it's again released to the other water users. So if we look at these two scenarios, we may find out that for most of developing countries, we have not much adopted, like we don't have these policies which are restricting some industries or water users to reuse water. So since sometimes it's really expensive to treat water to a point where it can be directly reused, then I think everybody who is running a business would go for optimum to optimize the profit. So nobody would opt to go for something that is more costful if they can still access water that can be treated in less cost. So since this is not in our policy then or our regulations, but it's advised, but if it's not like a must for all industries to reuse water, then nobody will go for it. They can just treat to a standard which can be indirectly reused as a fresh water, but it can just be released to the buffer environment where it can be cleaned by natural cleaning mechanism and go back to the treatment plant. So if we look at this, we may find that in United States, there are projects reported to be producing more than 370 cubic meter of water reuse per day in 2016. This is just for a one production industry. But in Tanzania, we have some of the industries which are practicing water reuse program, such as Tanzania Breweries Limited, among other industries. This industry practice the reuse of water, which is used in the cooling and bottle washing processes during the manufacturing process. Let's go to the next, please. So if we then, why do we need to reuse water? The wastewater is now recognized as an economic good, and the emerging technologies can treat wastewater, but the treated wastewater should be, if it's treated to a quality that can be supplied to the users, then the price should not be like higher than the price of the potable water. So we usually look for industries which supply water to the, sorry, go back. Hello, Mommy. No, next. Yeah, thank you. No, back. Yeah, so if whoever tries to treat water should be treated to a point where it can be reused by water users, but it should not be in a price higher than the normal price of the fresh water abstracted from the water supply sources. But now you find sometimes it's hard to treat water to a quality that can be reused, but with selling water at the same price. But again, the degree of wastewater treatment depends on the wastewater quality and the intended use. Because if we are treating water to use the water for agriculture, the quality should not be as water that is going to be treated to be reused for the domestic use. So the treated wastewater from treatment plants may be of better quality than raw water if the natural source of the raw water has been polluted by industrial effluents which have maybe heavy metals and other harmful pollutants. So sometimes for some areas, it's easy to treat wastewater to quality that can be used rather than treating water from the sources which are heavily polluted by some industrial effluents, since you may need more funds for such treatment compared to the treating the water which was reused, which was used in other uses other than the industrial effluents which have those harmful chemicals. So in such case, it could be financially feasible to produce potable or non-potable water from wastewater rather than relying on the very high polluted water from the industries. For example, in our case, if we look at the 𝐀𝐻𝐭 River, the water flowing in the 𝐀𝐻𝐭 River, it's really very much polluted, since most of the industries release their effluents to the 𝐀𝐻𝐭 River, which makes the water highly polluted to a point that treating the water may be of very high cost compared to treating retreating water which was used in the domestic purposes, where the pollutants which are to be removed are not as hard as the pollutants which are to be removed from the water from 𝐀𝐻𝐭 River. Next, please. Thank you. So we need, after looking at all this, then we need to supplement or augment the water which is available by looking at the different other water sources. And we do have what we call fog harvesting or atmospheric moisture extraction. This is a technology which has been in place for some times, but in Tanzania, it has not been so much implemented. And if we talk about fog, it's water which is in a gaseous form, which condenses and drops its ambient temperature to a dew point, forming small droplets that are suspended in the air. And this is mostly applicable in the semi-arid and arid regions, where fog is often the only or the main source of water, sustaining local fauna and flora. So if we look at the areas which are arid or semi-arid regions, the plants and animals relies on this fog water to for its survival. So we do have technology for extracting this water in case like we really don't have an alternative for the water source in that particular area. And also we have some other conditions which guides using this technology, like humidity and other atmospheric conditions. So in the world's largest fog harvesting project was built in Morocco, and produces water to supply about 1,600 people through 26-kilometer long pipeline. So if we look at this, that means if you the water harvested from this particular technology can be piped to 26 kilometer and supply 1,600 people exclusively without other sources, we may see that this is a potential water source. However, it's a little bit expensive, and so having it exclusively supplying such a community may be a little bit expensive compared to other sources. But when we don't have options, we have to go for it. We will have no option. So the fog harvesting project also has been implemented in Tanzania, in Babati region, and this project supplements water supply for 14 schools and surrounding communities using Cloudfisher Pro and Cloudfisher Mini models to capture water from the air since 2017. So this has been implemented in Babati region, but it's supplementing other sources in case the other sources are not functioning. They go for this water harvested from fog. So
Hello, I'm not sure if it's Dr. Clarence's internet or my internet.
the project
Can
has
the rest sorry, Dr. Clarence, we have lost you. Dr. Clarence?
Yes.
Okay, sorry for a bit. I think there's a connectivity issue.
With me?
Yes. There's a connectivity issue. But maybe you can just repeat that last point before we invite, I think it's Albert. He's been raising his hand for a while.
All right. Yeah. So I was explaining about fog harvesting, which has been implemented in Morocco and also in Tanzania. It has been implemented in Babati region, where it serves primary schools and the surrounding community is a water supplement when the other reliable sources are not available, or when it's during the water crisis, then they just switch into the water harvested using this fog harvesting technology, and this helps the students improves water access, and also it prevents the students from spending most of their time in fetching for water, and also it improves the sanitation facilities in these schools and also the welfare of the community in the surrounding environment. Yes. Is there any issue?
No issue. Yes. Maybe we just invite Albert, because he's been raising him.
Okay, thank you, Doctor. I had one question regarding on the economics of water reuse. I think it was a very nice presentation. I appreciate that. But my question is on maybe if we have any practical examples for water reuse projects in Tanzania, because I've seen you have mentioned some of the areas or regions that are out of East Africa. So I just wanted to learn if we have any kind of a water reuse project in Tanzania, which is maybe significant to the community, has any significant impact to the community. But also the second question is on the issue of fog harvesting. You gave an example of the Babat, if I get you correctly. So I just wanted to know the magnitude of that supplementary type of projects
which you say that it can add like reducing the water coverage, increase the water coverage for the schools, for the pupils. So what is the magnitude of that additional type of water supply to that school? Is it significant, or it's a type of research that maybe it was conducted to that area? Thank you. Over to you.
Thank you so much. I don't know if we should respond to this or finish up the presentation and come up into the Q&A session. Yeah, I think let me respond to this and finish up the presentation, because I think I'm about to finish and then we come up into Q&A session. So if we speak of the water reuse relevance projects in Tanzania, which can significantly impact the community. Currently, from my point of understanding, I don't know if there is a project that can significantly impact the community, which is practicing water reuse. But rather, I have examples of the industries which are practicing water reuse, and they use this water, which is treated for purposes such as like Coca-Cola company and also Tanzania breweries. They are practicing water reuse, but the reused water is only used for washing bottles, and also they use the water for cooling system during the production, and also in the sanitation issues such as in flush toilets and all that. But the project that has been implemented to benefit the community, I have not come across such project. And looking at the magnitude of the water from the fog harvesting, which is implemented in Babat, this technology has been used. It's practical, but also it's functioning, and it's supplying water to this community around. And the installed machine, I think it has the capacity of supplying 5,000 liters per day. So if you can look at this data, you may find that this is quite amount which can be just used for the these schools which are like they are not boarding school, just for the sanitation and other like hand washing and all those like minor activities. They don't have intensive water use. And also they do have other sources such as boreholes, but they are not so much like they are not sustainable, and they are not providing significant amount. That is why they came up with this. Also is a pilot study, because as I said earlier, the fog harvesting is mostly implemented in areas which are arid and semi-arid regions. And we do know that all these central zone from Dodoma to Singida and Babati, they are all semi-arid region, which has very much limited surface water bodies, which is always seasonal, and their main water source is groundwater. So if the institution has no capacity of drilling the deep borehole, which is very much costful, they need to have other technologies. However, having fog water harvesting is also costful in the initial investment, but thereafter you may have it used for several years, providing water for those minor activities. But if you are looking for water for like agriculture or other intensive uses or industrial uses, which is using water as the manufacturing agent, relying on the fog harvesting may be so much costful. Thank you. I hope I have answered your question. Otherwise, let's finish up the presentation and then we'll come to the Q&A session. So we need to meet our water demand. Now, how do we meet our water demand? We first have to decide where to place an industry. If we are constructing an industry for a certain purpose like production or processing or assembly, whatever they use, then we need to decide where to locate our industry depending on the source of water for production and domestic, because industry need source of water for production and also we need water for domestic purpose, because we do have employees who are spending most of their time there, which needs also water for drinking and other sanitation issues. So the sources may include public water supply, hiring a private service provider, or produce your own water, like now rainwater harvesting or fog harvesting, or you may have hiring a private service provider who can bring water with disposals, or you may have a private water provider who can who can drill borehole and supply you water for your use. This is an example of also the Tanzania breweries. They had their wells drilled, but they overused the wells and they had the problem of saline water intrusion. And finally, they had hired a private water provider who drilled several boreholes at the Uhuru Mchanganyiko Primary School, and they are supplying water to the TPL. So you may also have public water supply, where we know we may have water supplied by the water supply authority in your area, or you may have drilling your boreholes, but drilling boreholes you need drilling water well drilling permit from the surrounding water basin office, and also you will need to pay your water user fee annually. So we do have other factors that we need to consider when we are to construct our industry in a particular area. We need to know the water quality required for the plant water use. We also need to know the availability of water sources at the site of the industrial plant, if available. If not, then we have to go for other options. We also need the type of water source and flow rate, because you may have water source, but the rate is not sufficient for the intended use. You may also need seasonal variability in flow rate, including potential water crisis. So we do have some water sources, like we are depending, Dar es Salaam is depending on the water source from the major source of water from Ruvu River. But sometimes when we are in low season, we find out that we are not having enough water to be supplied to our industries. So we have to take care of all that, knowing if the area where we are locating, if the water is available throughout the year or it's just in a particular season, then we have to go for a supplementary source, which will be ready to supplement it during this crisis. We also need raw water quality parameters and sustainable water use. Yeah, go to the next. Next. So we also need infrastructure, to know the infrastructure needed. Yeah, we need to know infrastructure needed for harvesting raw water. We also need to know the investment cost for the facilities required Operational costs of the facility, including costs associated with the water use charges, maintenance of the water infrastructure, sludge disposal if water is treated on site, management of the waste collected from the surface water intakes, suitable skilled employees are required for installing, operating, and maintaining water treatment plants and water quality. So we also need regulatory requirements, including water use rights and permits, and also it's necessary to have environmental licenses for discharge permits, because after using water, you have to treat it and discharge to the environment. Then you need the discharge permit for the day-to-day compliance check and release to the environment when it's complying to the given license. Next. Yeah, so we do have these supplementary water sources. The fog can be used as a supplementary water source. And also, we may have water supplied from different sources. If the water, if we want to construct our industry or any manufacturing or any activities which demands water, we may have water not available in that particular area. So we may usually source water from further away, which can be transported to the area where it is needed. And we have seen several examples of water being transported from distance and being supplied to other areas, because we cannot all do our activities in the area where we have sufficient water for our operations. We need to have all these economic activities done all over the country. And again, if we don't have water source available, we can always rely on the having water transported from other areas to your area. So the long distance transfer of water between hydrological basin is always referred as interbasin water transfer, and water can be transported in rivers, open channels, tunnels.
Hello, Dr. Clarence?
Or later. Yes, when my phone rings, I'm connected to the internet from my phone. When it rings, I have disconnected internet. That's why I had to at least cut off the call first and then continue. Sorry for the interruption. So looking at the supplementary source, we may have water transferred from the distance. We may also have water transported through open channels, tunnels, pressurized or non-pressurized ducts, or in combination of one or more methods. So we may also have rainwater harvesting as supplementary source. We all know what rainwater harvesting is, and always the water harvested from the rain is always less costful in treatment. So this is an option which only need the initial installment, but after initial installment, we may always go for easier water treatment and water available throughout. The other, we may have water treated from the seawater, which is really very much costful. It cannot be an option if we do have other water sources, but if the need be, then that may be an option. If you look at the regions like Arab regions, which are most of them in desert, then they don't have precipitation, they don't have rivers, they have nothing, they don't have groundwater since they don't have recharge, so they always go for the seawater desalination. And also, groundwater is commonly used as a major water supply, requiring less treatment for industrial use compared to the surface water. Next, please. Yeah, in conclusion, we see that water is a vital resource in our industrial operations, but sustainable management is essential for ensuring its sustainability and security. Understanding the water cycle, reuse methods, and innovative techniques like fog harvesting, rainwater, and other water uses, we can optimize water resources. So exploring supplementary sources and conservation strategies will help meet our growing water demands. Effective policies and community participation are key approaches to secure water for future generations. Yeah, thank you. If you have questions and observations and contributions, you are all welcome. Give back the mic to Mwamini to open up the forum for the discussion. Thank you so much for listening and attending.
Thank you so much, Dr. Clarence. A round of applause. Thank you so much for the exhaustive presentation. Now we're opening up the floor for questions. I see Albert's mic is on, so maybe we can start with Albert. Yes, Albert.
Oh, sorry, I think it was a last time question, so I don't have any more questions. Thank you.
Okay, any questions, contributions? Because this session not only aims to, like Dr. Clarence is an expert, but it doesn't mean that she knows everything. So just in case someone wants to top up on what was presented or share an experience from their professional life, please feel free. We want this to be as interactive as possible. Thank you, Benjamin. Please.
Yes, thank you. Just a quick question to Doctor regarding the fog project. I think you said that it was a case study. Do you? I mean, what is the sustainability of that project, and in terms of the investment against what you are getting out of it, and is it a viable solution to those? Okay, you said high humidity, high humidity region. Is it viable solution when you look it in a sustainable way?
Yes, Dr. Clarence, maybe we can respond to Benjamin's question first before we open up the floor for another question.
All right. Thank you, Mr. Benjamin, for your question. Yes, this is it's a case study, but at the same time, it's working, and it's providing water to supplement other sources in this particular area. From my view, what I can say for this particular project, the investment is high. The investment cost, and I think I said before that if we just need water source for just normal routine uses like water for toilets, water for cooking, drinking water, this can be a viable solution. But if we are looking for something for a kind of business, if we are like doing manufacturing using water, or if we are like having food production using water, then we cannot go for this because the investment cost is higher, and also the water produced is not as much as you may need. So we may not opt this. We may even go for having water transported from a distance to your area, or look for other alternatives like rainwater harvesting. If possible, we may have dams and construct dams and harvest water during the rain season, and that can be used in the dry season, but it cannot be in the projects. Thank you.
Thank you, Dr. Clarence. Benjamin, unless you have a follow-up question following that response. No? Okay. No? Okay, you have? Okay.
Yes, no, this is not only for the question to the doctor, but I think it generally, as doctor mentioned, that there are no policies that are guiding the industries or the commercial buildings or something to do the reuse of the water, or kuonyesha kwamba kuko na a need of having a wastewater treatment plant. I don't know if there's any, and what do you think that can be done to implement this policy? Do we have to change the policies? Do we have, or what can be done on ensuring that it's one of the thing that can push these technologies and everything, and I'm so sure it's going to save a lot in terms of when you look at it in terms of sustainability.
Thank you so much, Mr. Benjamin. Thank you, Benjamin. Thank you so much, Mr. Benjamin. First, to get it correct, we do have policies that need us to have water treatment plants because we need to comply to the standards before we release water to the environment, or before it's released to other uses. But what I'm saying is, I'm not aware of the policies that demands these industries to reuse water, because you may treat water to the standard that can be released to the environment, but it cannot be reused. Like you cannot reuse it in your other uses in that particular industry. So that is, I think, so let's be in that page.
There is
I think we had somebody from EWURA. Maybe he can help us on that and tell us if they are having any issues that is like demanding the industrial water users to have water reused. Because like I have been in Egypt for sometimes back, and they do have this policy that you cannot just use water once and release it to the environment. The water should be reused 3 or 4 times before it's released to the environment. So you have to treat water to the quality that can be redistributed back to the water distribution system for different purposes. So we may have people who are participating in this. They can let us know. Maybe we do have these policies, or we do have the guidelines which are demanding these water users, industrial water users specifically, or agricultural water users, to reuse the water before it's released into the system.
Sure.
Okay. Thank you so much, Benjamin, for that input. Just reading from the comment section, Albert also agrees that we probably don't have maybe a specific policy. Wait, I don't think we have that policy. Only what we have is effluent discharge permits. So I think let me just check. Maduhu is here, unless Maduhu wants to respond to that, even though we're not putting any pressure for him to respond as Ewura, like formally. So we're not going to take maybe your opinion formally. It's just based on what you know, like just a learning environment. It's just a classroom. But if you wish to contribute on that, Maduhu, welcome.
Thank you, Mwamini, and thank you, Dr. Clarence. As a ruler, our mandate is to ensure the quality of water supplied to the environment, and is a quality of effluent discharged to the water bodies and receiving environment complied with the TBS standards, both 2016 and 2018 for water supply. Currently, we have known that policy which requires industries and water utilities to ensure their compliance on the use of wastewater before discharging to the environment. And it should be well known that EULA only deals with urban water utilities, not industries. I think NEMC will be in a good position to explain to this issue. Also, Dr. Clarence, I have my questions and I need clarification. First one, as a country, our approach to rainwater harvesting is very low. So I want to know from your side, what should be done to improve this approach, this situation? We are in a position as a country, we have a potential to collect rainwater from various activities, both on our houses, institutions, and even on ground. But when you go to data, you can see our utilization of this approach is very minimal. So I want to know, Doctor, what should be done to this? Another question, Dr. Kisiki, I want to know, are we little in need of using this fog harvesting in Tanzania, while we have multiple sources of accessing water supply? Thank you.
Thank you so much. Yeah, thank you for these questions, and thank you for the response, for the first response on the discharge permit. If we first look at the rainwater harvesting situation in our country, we do have this song sung all the time about rainwater harvesting, but the implementation is it's not promising, and we have seen several periods where we suffer a water shortage. It's a water crisis, and I think we are about to reach that time if something should not happen anytime soon. because we have had most of the areas around the Salam, they have started crying of the water shortage. They are not having water supply for 2-3 weeks now. So if we imagine if somebody had 10,000 liters rainwater harvesting, water storage, they should not be suffering that crisis for now, right? So, if we look at this rainwater harvesting, it can be done in small scale, in large scale. In large scale, we may have these large storage facilities like big dams, like we do have Kidunda Dam, which I heard it's going to be inaugurated today, to start the construction processes. So this is a very big infrastructure that is going to be constructed for the water storage that can be used to supplement water supply in Dar es Salaam city, and I think in Dodoma city if possible. So I think what should be done, we may start with the very small scale, like just the public institutions like hospitals and primary schools. Instead of depending on the water harvesting, water supply from the water supply utilities, we may go for rainwater harvesting technology. And its implementation is not even very much costful, having those gutters constructed and just having the water storage tank constructed. It's a one-time investment which can last for more than even 10 years before you even go for the repairing or renovating the water collection infrastructure. So I think we may have that policy guiding all primary schools having the rainwater harvesting in place. From that point, I know few people around the school may be served with same source, and also this primary school and secondary school and public hospitals may be having access to water for the longer period, and if the need be of having the water supplied by the authority or the utility supplying water in that particular area, it won't be so much demanding. So that will give these water supply utilities a relief of not having so much water supplied in such areas. We may look at the example of University of Dodoma. We have seen that university suffering from water for very long time. They do have water, but it's not easy to supply all that university with water, where for now the only source of water for Dodoma region is only groundwater, where we are now looking forward to have water supplied from the new Kidunda Dam, which is about to be constructed. And we sometimes back had a government thinking of transferring water from Lake Victoria to Dodoma to augment the source which is currently available. But those are all very costful projects, but if they will be implemented, they will be a sustainable source for this city. But now if we look at the University of Dodoma, they have so many built structures where they can install this rainwater harvesting system, and they will have so much like very big storage tanks which can store all that water that can supply that university even for 3 to 4 months before they demand for water supply from other sources. So if we move into having this as a policy that guides these public sectors or institutions having the rainwater harvesting system in place, I think it will do so much help in terms of saving the suffocation which always comes every year in the dry season.
Thank you so much, Dr. Clarence, for that exhaustive answer. Indeed, the questions shared by Benjamin and Maduhu are thought-provoking. And we highly appreciate it's very good for this learning environment.
Thank you. Sorry, Mamini. I think he had the second question, which was asking if Tanzania needs fog harvesting. He had the second question. Sorry for interrupting.
Oh, no worries, no worries. Okay.
Yeah. So as I said before, like few months back, we also had people from Korea who came up with also with atmospheric moisture extraction machines, which were costing like 300 millions for one machine that can extract like 3,000 liters of water per day. Yeah, so it was like this is more or less the same thing. So if we look at these technologies, they are really expensive, because having 300 million installed, which can produce only 3,000 liters a day, that is very small amount compared to the investment cost. But now, if the machine goes to the end users, like first, it depends on the maintenance cost of the technology. But if we just have one-time investment, and if we do have these investments done in areas where the other sources are really problematic, we may have, as we said, this technology is mostly suitable in areas where there's a arid climate. And the areas with arid and semi-arid climate, and as we said, we do have one rain season annually, and also we now during this rain season, that is when we have surface water flowing. The moment rain ends, that is the end of the story of surface water. It may last for just 1 month or two, then that is where the story of surface water ends. And in that case, we may have this in place, fog harvesting in place, if we only need water for, if it's intended for end users. Like, we are not investing this fog harvesting for a business purpose, as I explained earlier. We may have this if they are just intended to if it's just intended to the end users, like they are just using water for their own use, not having it produce something that need to be sold for a profit. This can be taken as an example, like we may have these filters, like the filters we can use to filter water in our households. They are small filters which can be sold at higher price, but it can be used if you have it to filter water for your own household, just for like 5-8 people. But if you are to buy such filter for filtering water to be packed and for a business, that can be cannot be useful, because you will end up having a small filter that filters a very small amount of water, and you need to produce very high per day. So you will end up having so much investment that you cannot have the return as expected. So that is how this fog harvesting works. We need it when we don't use it for a business purpose. Thank you.
Thank you, Dr. And I appreciate your answers. Back to the rainwater harvesting, I should pose a challenge to you and the whole community of Water Institute. I have been there, and nowadays I can see you are rehabilitating those lecture rooms. You should be champion rainwater harvesting by installing rainwater infrastructures to those new lecture rooms. Thank you.
Thank you so much. I've taken the challenge. We'll work on it. Thank you.
Thank you.
Thank you so much for that question and the exhaustive response. Do we have any more questions? Any input?
Yes.
Okay, welcome, William.
Thank you very much. My name is William Gilling. I just want to reiterate some of the issues that Dr. Clarence raised, particularly on reuse. There are actually in Dar es Salaam places that I know that reuse water. Now, they are not, how should I say, industrial, but rather private. So if there was a way to align and know who these entities are, perhaps we could use them as case studies to help some of us. I'm in the industry, so I do know, and I'm not gonna put up names out here before getting permission from them. But they're there. So reuse is being done. Perhaps it's not at a larger scale, but using these institutions as well as entities, we could come up with a way to use them as case studies. And that is all.
Thank you so much.
Thank you so much, William, for the input. Do we have any more additional comments, questions? Okay, I'll just quickly call up names. Ali, are you comfortable? Ali Mjawiri. Okay. Next is Concedo.
Hello.
Oh, Ali. Okay, yes. Welcome.
Okay. I'm Ali Mjawiri from Zanzibar. In Zanzibar, we have projects of reuse of water for marine investment or marine conservation, because many people who are not educated about the reuse of sewage water, but now we have a good project for protection our environment in marine project protection. This education is better for me because I understanding all of what government needed to improve our development for the use of water, sewage. Thank you.
Thank you, Ali, for sharing the Zanzibar perspective. Concedo. Concedo, do you have any contribution? No? Okay.
Yes. You can continue. I don't have any remark on that.
Okay, perfect. Dinus? No? Okay. Edgy Lorian? Anything from you?
Yeah, for me, I think there should be something like to push these big companies who are polluting water. I mean, who are using water and polluting, like to reuse the water actually. And maybe there's one guy who told me like sometimes the water for example, from our toilet can be used to make fertilizers. So those kind of things, I think the government should push the industries to think on these issues which I've mentioned, to reuse water or to pay tax in a way like they will see that they should recycle. If they don't, they will suffer tax. So that's
okay. Thank you so much, for that like policy recommendation. Elizabeth, do you have anything to add?
Thank you for the good presentation. On my side, I don't have any additional comments.
Okay, thank you. Flora?
Thank you, no.
Okay, Mr. Mrema, you joined us. Welcome. Frederick Mrema. Mr. Mrema. Okay, I'm not sure what's happening.
What about now?
Yes, we can hear you.
Good afternoon, everybody. I'm sorry I'm late. I joined you a little bit late, and thank you for a very good presentation. However, I could not see the, display the presentation I was just hearing. Nevertheless, I could harvest some good things. I don't have much concern. It's only one point I have in regard of the, water production and the Hello?
Yes, we can hear you.
Yes, water production and also the water reuse for the waste management, sanitation, and so on. My concern is about the regulators. In my observation, I think in this country, we are almost over-regulated. Whatever you touch, the regulators are on you. And I do not know if we hear the case of deficits of water production at the moment. And if people try, I know people, for example, in Dar es Salaam, quite a number of them are having boreholes and so on. So I do not know about the regulators, whether their intervention of trying to regulate this, whether they are discouraging or becoming disincentive or what, because in this context of regulations, there are costs involved. The same case, which is synonymous to this, is a waste management as well, is an issue. We are producing, we are using a lot of water and it's going wasted, and some, like we are hearing, going into pollution and so on, but that this can be now reused. But again, there are some costs involved. It is exactly the same as the previous presenter, observant said about the giving incentives of these people who can, make use of this as a product again for the maybe land scale or whatever, and give them motivation in terms of tax returns or what have you. So, and good enough, I think, Dr. Clarence, you are coming also from this Water Institute, is not far from the regulators, probably. If we can do more, actually, to have the government and the regulators more involved in such a way that some incentives can be given to the people who are trying to produce more water, and also those who are trying to recycle the water. Thank you very much. That was my input.
Thank you so much.
Thank you so much, Mr. Mrema, for the input. It's another policy recommendation. Thank you so much. Jasmine?
Yes. Thank you so very much for the presentation. We learn a lot, and I'm agree with Mr. Frederick Mrema. We need regulation in this part, especially in water reuse, the part of rainwater. Thank you.
Thank you, Jasmine. Joseph? Joseph, any comment, input? Basically what you gathered in the session? No? Okay. Lamek?
Thank you very much, Muamin. I've learned a lot about on this presentation today, and almost every speaker just said whatever I was thinking about on this issue of water. The big issue for me, I think it is the regulators. So it's the policy issues. If they address that, probably we could not have this water scarcity issues. Thank you.
Okay, so I'm gathering the sentiment is that regulators are contributing to water scarcity. Sophia, last but not least. If you said something, yeah, now we can hear you. See you on mute again. Okay, let me just unmute it for you so that you just start speaking, okay? I'll just unmute it for you. I'm not sure what's the problem. Could you unmute yourself?
Did you hear me? Did you hear me?
Now we can, now we can.
Yeah.
Now we can.
Okay, thank you for the good presentation. I enjoyed and I'm happy. But for me, there is no comment. Everything was already elaborated. Thank you.
Okay, so that's everyone. I think we have almost everyone. Yeah, everyone has spoken or participated in one way or another. Dr. Clarence, I think you didn't have many questions. Like they didn't have many questions for you because perhaps the lecture or the session was very clear. So maybe if you have a few parting words before I explain about next week's update.
Yeah, I just thank all the participants for attending and your availability towards the end of the session, because it's a little bit long, but according to our schedule, of course, but having people online for all this time, sometimes it's not easy. So I just ask you to participate in the coming webinar in the which is next Wednesday at the same time. We'll be in the same venue, so you are all welcome, and tell a friend to invite a friend in this insightful learning process, which will update you with some water issues and environment and other issues, and you may raise, even if something is not in our content, you may raise and we may discuss here, and it will be more insightful. And thank you for your participation, like live participation after the presentation. Thank you so much. I'm hoping to see you in the same venue and same time next Wednesday. Thank you, Muamin, for your coordination.
Thank you, Dr. Clarence, for your availability as well, and everyone who managed to participate in this session. I think as one of our takeaways, we'll try to make other sessions more interactive because and less of a presentation to allow you to engage more with Dr. Clarence and fellow participants. But other than that, as you know, this material, we got it mostly from AHK Brazil. It was developed by Dr. Craig, who implemented IWAMI in Brazil, but we also sourced some of the material from AHK Southern Africa, and Dr. Clarence has led the development of most of the content. So as a next step, it's you'll receive the module in PDF format, which has more exhaustive information, but you'll also receive a copy of the slides. But all of these will also be available on the e-learning platform at ATINGI, which will be, the e-learning phase will be activated next week. So thank you so much for your time and efforts, and we hope to see you again next week.
Thank you so much.
Bye, everyone. Thank you.
Bye-bye.
Bye.
No
Bye.
photo
Thank
session.
you.
Women. Photo
Okay,
session
bye.
today. Are we having a photo?
Oh no. Today, just a second. Just a second. I'm trying to stop the recording. I'm trying to stop the recording. Okay. Okay, there it is. Stop recording. Stop.